Hello, welcome to Algebra 1 with Miss Andrea. We're going to continue in this unit exploring the, not exponential, I'm sorry, quadratic equations. And today we're going to continue with getting into factoring those equations. Okay, so this is going to be module 5 online. The units got messed up in the book online. If you're following online in the book, it's called unit 3. The main thing you need to be aware of is that this is quadratic equations, and it's going to be page 4. So this is lesson 5.4 or module 5, page 4. All right, so getting into the lesson here, we're going to continue with factoring. Like I said, we previously learned about common factor factoring and using the GCF. So now what we're going to get into is trinomial factoring. Remember what a trinomial is. A trinomial is a polynomial that has 3 terms. So if we think of our standard form of a quadratic equation, we have a squared plus bx plus c, and then it has an equals 0 at the end. But if you just look at this expression on the left-hand side, this is a trinomial because it has 1, 2, 3 terms in it. So that's what makes it a trinomial. So all quadratic equations are going to be trinomials, even if you're missing, like, say, the constant, because you could always put plus 0 in for that if you wanted to, right? And so a quadratic equation in standard form is a trinomial. We'll be focusing on this lesson on factoring quadratic equations whose a value is 1. So here's the standard rule. Ax squared plus bx plus c is that is the product or the expanded form of the polynomial, okay? So the factors or the factored form of the polynomial is going to look like this right side right here. X plus n1 times x plus n2. This first one here, this is the first factor, and this right here is the second factor. So we have 2 factors, 2 things that we're going to multiply together with themselves to create that expanded form, or the product, the polynomial over here on the left side. Okay, now some special things of note here. When you find, in order to figure out what these factored forms are, you have to see that n1 plus n2 is going to add together to be this b right here. So n1 plus n2 is going to equal b. Those same exact numbers, when they're multiplied instead of added, is going to be a times c, okay? So a times c. Now let's think about this. How will this change? How will this formula change if our a is 1? Well, 1 times x squared is simply going to be x squared, so it'll just disappear over there. And a times c is simply going to be c if a is 1. 1 times c is just c, so that's going to disappear as well. So let's look at what this looks like when we drop the a's. It's just going to be, we're looking for 2 numbers, number 1 and number 2. 2 numbers that, when multiplied together, are going to equal c, but when you add them together, they're going to equal b. So that's the first point you need to remember when you're thinking about factoring trinomials. Then there's 2 more things to pay attention to, and that's the signs, the first sign and the second sign. We're going to start here with the second sign, okay? If it's positive, that means that our signs in our factored polynomials are going to be the same. If it's negative, that means that these signs are going to be opposite or different. So in other words, one will be plus and one will be negative, okay? So what does that mean when we look here? Okay, well, if they're the same, then they take the sign. Both of them take this sign, whatever it is, if it's the same. However, if it's opposite, then the bigger number gets the sign, gets that plus sign there. So I'm going to put some examples here off to the side to see how exactly that works. So if we have x squared, bx, and c, we're going to say that equals, we've got two factors here. Now, because these all have an implied 1, every single time you're going to factor these trinomials into two factors, it's going to just start with x and x. No matter what, it's always going to start with x if we have the 1 for the a. Okay, now that'll change when you don't have a 1 for the a, but if you have 1 for the a, it always starts with x and x. All right, so now let's look at this. If we say have a plus here and a minus, let's choose a different number or color for minus, and a minus here, what is this going to tell us? Okay, this plus right here tells us that these two are going to have the same sign, okay? And this value, this sign right here, the minus sign, is telling us that we're going to have those same signs. They're going to be negative. This is N1 and this is N2. Okay, so right now we're only looking at the signs, different examples with the signs. So let's erase that and see if we can come up with, oops, it erased everything. All right, X, N1, X. All right, so let's see what would happen if it was minus and plus. Well, the minus here is going to tell us that we're going to have opposite signs. So one's going to be positive and one's going to be negative. And this right here tells us that the bigger number is going to be positive. Well, right now we have N1 and N2, so we don't really know which one's bigger. I'll just call N2 bigger, and we're going to put the plus there and the minus there. So you can see how the signs also help us formulate what our factors are going to be. Okay. So 3 points to remember. Point 1. Essentially, you need to find two numbers that when added together will equal b, the coefficient of that middle term, and when multiplied together equal c, the constant at the end of the trinomial. And then you need to remember that the second sign in the trinomial is going to tell us if our factors will have the same or opposite signs. And then the first sign gives us some additional information. If we have the same sign, it tells us what they both are. But if we have opposite signs, it tells us the sign of the larger value. So let's put this information to use here. We're asked to factor x squared minus 3x minus 10. All right, so I know that what I want to find is going to be in a format like this. And I know, since I have an implied number 1 here, that this is going to be x and x, right? Now, I have some information over here for us that helps us understand why we're going to multiply and add to each of these numbers. We can see that b is -3 and c is -10, okay? So we know that we're going to factor to this format. We're going to have an N1 and an N2, right? Well, if we were to FOIL these, FOIL, remember foiling? That's when you distribute and you're going to multiply these together to expand them to make our larger polynomial. Well, first, x times x is x squared. O outside is x times N2. Well, this one would technically be outside, right? And then inside is N1 times x. So we'll just go ahead and put those there. And then last is N1 times N2, okay? And then you combine these two like terms. That's why it was okay for me to switch up their order, because when you have an x and an x, those are like terms. So we're just going to add the coefficients N1 plus N2. So you can see how that is b. We have an implied a right here of 1, and then N1 plus N2 is the b, and N1 times N2 is the c. So we can see that the two numbers that we need to find are going to have to multiply to be -10 and then add to be -3. Let's see what we've got here. Okay, that's exactly what I was saying. And then, oops, I didn't erase all of that. So we're looking for two numbers that multiply to equal -10 and add to equal -3. So now we get into the signs. The signs. All right. Let's put this right here. That's where I'm going to be working on this. I know that they're going to multiply. What I remember from my last one is they're going to multiply to be -10, and they're going to add to be -3. So I'll think of some numbers later, but first I want to look at these signs. I know that my first sign right here, this sign right here, is going to tell me, since it's a negative, that means that I'm going to have opposite signs. So I'm going to have one that's plus and one that's minus. Now right here, this negative right here is going to tell me that the bigger number is always going to be negative. So we're looking for two numbers where they multiply to be -10 and they add to be -3. I think, actually, I have some more. Let's see if we have this set up here. Yep. And of course, it didn't line up exactly. So let me try that again, writing these out. We have x, and we determined that they were going to be opposite signs, and we determined that we wanted to multiply to be -10 and add to be -3. Okay, now let's actually do some work. All right, so let's think of some factors that multiply to be -10. So we've got 1 times 10 will be 10, 2 times 5 is 10, no 3, no 4. Okay, so that's all my multiples of 10. Now, if it's negative, I know one of these has to be negative. And I learned from my sign right here that the bigger number is the one that's going to be negative. So let me throw some negatives up in there. And then when I add these together, 1 plus -10 is -9, and 2 plus -5 is -3. And what are we looking for? We're looking for -3. So these are my answers right here. So N1 can be 2, and N2 can be -5. And that's what my answers are. I'm going to put my -5 right here, and my N1, I'm going to put right here the +2 and then the -5. Now, this order does not matter. It could have also been written as x minus 5 and x plus 2. So the order of the actual the different terms, the x minus 5 and the x plus 2, that doesn't matter. What's inside the parentheses, that matters. You have to have x plus 2 and you have to have x minus 5. But which one of those two things is first? That does not matter. It's the same thing as 2 times 3 and 3 times 2. You get 6 both ways. All right, so here I have all that information written out in our notes, factors of 10. You can eat which one of these adds to be -3. And then we found it, yay. N1 is -5 and N2 is +2. So that the notes that I have here equal what the answer that's written in orange there. All right, so we've got another one to try here. Now, I know that I want my answer to be 2 polynomials which have 2 terms each, and the first term is going to be x. So I'm going to go ahead and write that out. Now, this plus sign right here tells me that each of these factors are going to have the same sign in their polynomial. And this right here tells me that they're both going to be plus. So I'm going to go ahead and write that down. Now I'm going to create a little chart here, look for what I'm trying to multiply and add. I'm going to multiply to be whatever C is. In this case, C is 8. So I want to find the 2 numbers that multiply to be 8 and add to be whatever B is. B is 6. So 2 things that multiply to be 8, 1 times 8, 2 times 4, not 3 times anything, and add to be 6. 1 plus 8 is 9, 2 plus 4 is 6. So it's going to be 2 and 4. So N1 is 2 and N2 is 4. I'm just going to go ahead and plug those in. My final answer is x plus 2 times x plus 4. Factor 1 is x plus 2. Factor 2 is x plus 4. And so we have here those same notes. X plus 4 and x plus 2, you can see that it's the exact opposite order, and yet it's still the exact same correct answer. So the order of each term can be switched, but inside the parentheses cannot. You still have x plus 2 in both of them, and you still have x plus 4 in both of them. All right, so now I want you to go ahead and press pause and work on these on your own, but I want to warn you, there's at least one tricky one in there. I know you can get it though. All right, welcome back. Let's go ahead and get started with these. We've got x squared plus 5x plus 6. Let's go ahead and get our factors ready. We know that when we have a trinomial with the leading coefficient, or the a of 1, that we're going to have our two factors be leading terms of x. Okay, now my plus sign here tells me that these are going to have the same sign, right? And my plus sign here tells me that they're both going to be plus. So now I need to find, what am I going to multiply to and what am I going to add to? Well, I'm going to multiply to whatever c is. C is 6 and b is 5. So I want to multiply to 6 and add to 5. So 1 times 6, 2 times 3. Those are all the factors of 6. Now let's see what they are when they add up. 1 plus 6 is 7. 2 plus 3 is 5. So it's not this one. It is this one. So x plus 2 and x plus 3. That's my final answer. That's the factored. The first factor is x plus 2. The second factor is x plus 3. All right, let's change colors so you can see my work here. I'm going to go ahead and put the factored form as two terms, two polynomials being multiplied together, both of which have a leading term of x. Because our leading coefficient is 1, I know that it's going to just be x. Then I know that they're going to have different signs, okay? So I'm going to go ahead and put a plus and a minus there. They have different signs. And I know the bigger one is going to be negative, okay? So here we need to multiply to be negative 12. And we need to add to be negative 4, okay? So let's look at this. 1 times 12, 2 times 6, and 3 times 4. My bigger number is the negative, so I'm going to put my negatives right there. 1 plus negative 12 is negative 11. That one doesn't work. 2 plus negative 6, that's negative 4. I'm pretty sure these are going to be my answers, but let's just double check this one. 3 plus negative 4, that's negative 1. That one doesn't work either. So those are my answers. A positive 2, that's going to go here with the positive, and a negative 6, that's going to go here with the 6, with the negative. All right, let me switch over to another color here. Set up my answer. Leading term is going to be x for both of these. I can see already that I'm going to have different terms or opposite terms, a plus and a minus, and that my bigger term is going to be a negative. So let me write a little chart right here. I want to multiply to be negative 30, or my c value right here. And I want to add to be my b value. Well, what's my b value? It's going to be the number 1, negative 1. When you don't see a coefficient, remember that's an implied number 1. So this should be easy. There's not very many multiples of 3. There's only going to be one multiple of 3, 1 times 3. So 2 factors. 1 times 3, I said multiples of 3, I meant factors of 3. 1 times 3, and we know that the bigger number gets the negative, so it's 1 times negative 3. And 1 plus negative 3 is negative 2. Oh, I wrote 3. This is 30. Oh my gracious. No wonder that didn't work out. All right, so let's look at this again. 30. 1 times 30. 2 times 15. 3 times 10. 4. I don't know if 30 is divisible by 4. It's not going to be divisible by 4, but I'm going to use my calculator just to confirm that. 30 divided by 4 is 7.5, so that's not it. 30 divided by 5 is 6. So 5 times 6. And then when we get back to 6, it's just going to repeat. So we're done. And it says, remember, our bigger value is negative. So all these are the negatives. Now, we need to add to find -1. What's 1 plus -30? That's -29. What's 1 plus 2 plus -15 is going to be -13. 3 plus -10 is -6, and 5 plus -6 is -1. So here I have my answers, a +5 and a -6. The -6 is going to go here with the negative, and the +5 is going to go here with the positive. Okay? All right, moving on. Number 4. Let's go ahead and do this. X and X. All right, I know that this is going to tell me I'm going to have different signs. And this is telling me that my bigger number is going to be positive. Okay, so I want to multiply to be -26. And I want to add to be a +11. So 26 is going to be 1 times 26, 2 times 13. Grab my calculator again. 26 divided by 3 is not a whole number. So let's do 26 divided by 4, not a whole number. By 5, not a whole number. By 6, not a whole number. 7, not good. 8, nope. 9, nope. 10, nope. 11, nope. And 12, nope. And then 13, we would start repeating. Since we have opposite signs, the bigger number is positive. So in this case, I'm going to make my smaller number the negative. That's our first time doing that. So it's good to see that example. So -1 plus 26 is a +25. -2 plus 13 is a +11. So I have my 2 answers here. -2 is going to go here with the negative, and +13 is going to go here with the positive. All right, so let's go ahead and set this one up. X, X. All right, so this tells me that I'm going to have both the exact same sign and they're both going to be positive. So we've got an X plus and an X plus. So let's look at this. We need things that are going to multiply to be 1, but add to be 4. Okay, multiply to be 1, that's just 1 times 1. Those are the only factors of 1 at all. It's not possible to have anything else. And 1 plus 1 does not equal 4. It equals 2. And that's the only factor. There's nothing else that we could possibly do. This one won't work. This one is already factored, or in its simplest form, it's already done everything that it can do. So think of the number 3. All that you can factor this out to is 3 times 1, right? So all we could factor out of this is a 1. 1 times this will give us this. What's that? What type of number is that called when the only factor is itself and 1? That's a prime number. So this is a prime quadratic equation or trinomial, okay? All right, so the very last one here we have number 6. Let's go ahead and set it up. We know that our leading terms are both going to be x because our a value is 1, or our leading coefficient is 1. And I know that both of my terms, or both of my polynomials, my factors, are going to have a plus sign in the middle. I'm sorry, not a plus sign. They're both going to have the same sign. And what sign is that? Well, it's a negative sign right here. So I've got 2 negatives that I'm going to be multiplying, okay? And I want them to multiply to equal their C value, which is 49. And add to be the B value, which is -14. Okay, so let's think of 49. We know that we have 1 times 49. Then we're going to pull out a calculator. Do 49 divided by 2. Oops, I did 48. 49 divided by 2 is Not a whole number, so let's divide by 3. Not a whole number, divide by 4. Nope. 5, nuh-uh. 6, not going to work. 7, okay. Well, 7 times 7, and then we go back to repeating. So I can't really continue on. I'm done factoring. My factors of 49 are 1, 7, and 49. And I know that they both have to be negative. Negative and negative, negative and negative. All right, so when I add these, negative 1 plus negative 49, negative 50. Negative 7 plus negative 7, negative 14. Right, here's my answer. Negative 7 and negative 7. So there you go. Factoring made easy for trinomials where the leading coefficient, or a, is equal to 1. Now, you thought we were done. We've got one more thing. You know that you can combine factoring methods. You can actually do both GCF and this trinomial factoring in the same problem. And that's going to make it a little tricky. It's especially important to pay attention to GCF. If you have something in the A spot, that's a signal that you might have a greatest common factor to take out before you can do the trinomial. Now we're going to get into other things where we can do some trinomial factoring in which A is not 1, and we didn't make it 1 using GCF. But in all of these instances, we're going to find a greatest common factor before we do the factoring we did before, okay? So the greatest common factor we're going to assume right here is going to be 3. So there's a 3 that we can take out of here. We can definitely take a 3 out of there and a 3 out of there. So we're going to start this by doing 3 times x squared plus, what's 21 divided by 3? 7x plus 36 divided by 3? 12. Now, within our parentheses here, we can break this up into 2 more terms. So we've already broken it up into 2 terms. Our first term being 3, and our second term being x squared plus 7x plus 12. But we can take this second term and divide it up into 2 more terms, which would end up with a total of 3 terms. Just like if we multiplied 2 times x times 5. Well, that's 3 different terms, and it all becomes 10x. Okay, so you're not restricted to only having 2 terms. In this case in particular, we're going to have 3 terms. So that's equal to, let me write my equal sign, 3 times. And then I'm going to have my 2 sets of parentheses. And because now my leading coefficient, or A, is 1, I can go ahead and plug in x's here and here. My plus sign tells me that I'm going to have the same sign for both of these terms. And this right here tells me that they're both going to be plus. All right. Now, I want something that's going to multiply to be 12 and add to be 7. So let's look at these. We've got 1 times 12, they're both positive, 2 times 6, and 3 times 4. So 1 plus 12 is 13, 6 plus 2 is going to be 8, and 4 plus 3 is 7. So right here, I have my answer, 3 and 4. So I want to point out to you real quick that we have 3 terms. Our first term is 3, our second term is x plus 3, and our third term is x plus 4. So I want you to pause the video and continue to do 2 through 4 on your own, and then come back and we'll go over them together. All right, so welcome back. We're going to go ahead and look at this next one. I see a 4 here, so I know for a fact I'll be able, because that's the lesson we're on, then I'm going to be able to factor 4 out as a greatest common factor. But let's verify this. If we divide the first term by 4, then we're left with x squared. If we divide the next term by 4, we're left with -2. And our last term here, divided by 4, we're going to be left with a 3. So let's look and see if we can make this into 3 factors instead of just 2. I know that since now my leading coefficient inside these parentheses is 1, my leading term in my two factors here are going to be just simply x, okay? And I know here, this is telling me that I'm going to have different signs. So I'm going to have 1 plus and 1 minus. And my bigger sign is going to be a negative here. Okay, so let me create a chart. I know I want to multiply to be -3, and that I want to add to be -2. So this should be relatively easy. 3 being prime, I know is going to be 1 times 3. And my bigger number is negative. So let me put my negative in. 1 plus -3 is -2. So this works. I'm going to plug a -3 in there, and a +1 in there, or 3 in the negative spot and a 1 in the positive spot. So my three terms are 4, x plus 1, and x minus 3. All right, moving on. Let's go ahead and take out this -2 here at the beginning. -2 times x squared. -24x divided by -2. What's that going to be? That's going to be a positive 12x. -22 divided by -2 is a positive 11. Okay, so let's go ahead and rewrite our format that we're going to be having our final answer in. I know from this sign that they're both going to be the same. Both of my second and third terms that are polynomials are going to have the same sign in them, either addition or subtraction. And right here, this tells me that they're both going to be addition. All right, so I'm going to want to multiply to be the C term, which happens to be a positive 11, and add to be the B term, which happens to be a positive 12. 11's prime, so this should be easy. 1 times 11, they're both positive, right? 1 plus 11 is 12, so this will work quite nicely for us. 2 is our first term, x plus 1 is our second term, x plus 12 is our third term. And we can switch those around. You will always want to have the constant in the beginning, but you could switch around and be 2 times x plus 12 times x plus 1. It's bad form to put the constant anywhere except in the beginning. So you do want to keep that in the front, but the rest of the other two things in the back could switch around. All right, here we have a negative. That's the only thing that we can take out, even if it's just a -1. If you have a negative in the front of something, you do have to take it out through greatest common factoring. Okay, so -1 times x squared. 9x divided by -1 is going to be -9x. -14 divided by -1 is going to be a positive 14. So let's rewrite this now. With our triad of terms, 1, 2, 3 terms triad. And they, both of these second and third terms are polynomials that are going to have a leading term of just x, because our x now has 1 as its leading coefficient here. So now, right here, it tells us we're going to have the same sign. And this tells us that they're both going to be negative. Now let's create our little chart here. We want to multiply to be a positive 14 and add to be a -9. Okay, let's think of some factors of 14. 1 times 14, 2 times 7, 3, 4, 5, 6, none of those work, and 7 brings us back around again. Now, we have the same sign for both of them, and they're both negative. So negative, 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 negative. -1 plus -14 is -15. -2 and -7 is -9. So these are our two answers, -2 and -7. Terms are -1, x minus 2, and x minus 7. All right, so we're done with that method of factoring. I'll see you in the next lesson to continue learning more about factoring.